SC42. He's going to be talking about security, business and architecture in DevOps 2. Thank you.
Hello everyone, welcome, and welcome back. I've been speaking at Whitehall Media for quite a while now, and I'd like to welcome everybody back for who is coming back. And for new joiners, welcome. I'd like to start with a very simple question. Who can figure out how Phoenix and security fits together? And how the hell are they related to risk? Can anybody figure it out? Probably not. That's why I'm here today. So, a little bit of a note, whatever I'm going to say today doesn't represent any organization that I represent, nor my organization. Just not for the record, I have to say. So, what we're going to talk about today is a little bit of background of what DevOps is, DevSecOps is, and then we're going to dive in. So, a little bit about myself. I'm Francesco Cipollone, Head of Security Architecture for GPM in HSBC, one division of HSBC. We're doing a security revolution in DevOps. And we're trying to insert effectively security in every life cycle, in every part of the organization. Starting from the engineering perspective, but expanding. And today, I'm going to talk to you about the security aspect and the risk management aspect of it. Because you're doing a lot of conference for DevOps. Actually, let me ask, who is involved in engineering today? In here? 1, 2, 3, 4, 5. Okay. Who's been on DevOps, DevSecOps, what is fancy term conference? 1, 2, 3, 4. Okay. How many times do you hear about risk management in those conferences? 0, 1, 2. Probably not. It's not an argument that is. It's not a topic that is usually discussed, but I think it's important to bring the organization along this conversation. Because a very simple challenge for you. If you have a vulnerability, is that a risk? Yes. Do the business need to know? Probably yes. So we need to involve the risk management aspect in whatever engineering does or whatever security engineering does. So as I said, I'm a seasonal advisor. I'm heading up the NSC42, that is a consultancy, and we're working with HSBC to create this program of work that is called Security Phoenix, and today I'm going to talk to you about the risk aspect of Phoenix. And also I'm heading up the Cloud Security Alliance, so I have a very long title. Apologies for the long title. Because we want to do that, also want to do the engineering part also in cloud, and we want to involve the organization that works in this cloud space to contribute back. So I have two things that I keep on repeating at every of my conference. Security is everybody's job. Everybody gets affected by security. If you make a mistake, as Sarah was saying, the whole organization gets affected. And one of my pet peeves is we need to make security frictionless. If we make it hard, complicated, people will go around us. That's why we need to make it cool and frictionless. So we level set more or less Dev and Ops and how they fit together in this world of DevOps. But now we insert another element that is security, and we insert another element again that is business and risk. So how the hell does business and risk fit together in DevOps? Anybody can figure it out. Anybody does risk management in DevOps or involve the business in DevOps? Show of hands. Okay, we have quite a few peer pioneers. Well done. Usually I have 0 hands. So we have 3 hands, 0 hands. Well done, guys. So that Security Phoenix is a program of work composed of different parts. So you have security by design, build and test, security operation, people and education and governance. And today we're going to focus on the risk management area. So the key things about DevOps is reorganizing the organization in a structure that is similar to this, especially the engineering department. You have a conceptual element called pods that is formed by engineers and developers with a new figure that is called a security champions that that effectively bring the security element down to this organization, down to this unit of people. And then you have the product owner that is effectively heading up this group of people and deciding what to build every day. And then architects and other elements. But fundamentally, this group of people are completely in charge of the life cycle, the life and death of an application. So how can we make them, how we can trust them and make them completely independent to decide the life and death of an application? We need to trust them, but also verify that they're doing the right thing. So from a security perspective, and I'm going to touch point on the risk management in a second, how can we trust people to do the right thing, and how can we verify that they're doing the right thing? If you boil it down to the core of the engineering, if somebody is introducing a vulnerability, how do I verify that they're introducing a vulnerability in an application or not? Some level of automation, yes, but we need to visualize that. So we're going to establish threshold and we're going to visualize the vulnerability based on security scanners with the automation element through the pipeline, so that we scan the code and then we visualize if the team is actually performing better or worse from a security perspective. Are they introducing any vulnerability? Yes and no. That's the first element for the trust. The second element, do they care about security? Do they keep a healthy balance between whatever they build and whatever they fix? All these two elements, together with the training aspect of security, going to give them a license to operate. That's your break, that's your kill switch for deploying stuff in production. That's how we trust them. So this is normally a life cycle for a software development life cycle. You start on the very left when you focus on assets. So asset is whatever your organization has, including the code. Then you move to the scanning. You do a number of scanning of the code, and based on the scanning, then you visualize. And based on the visualization, as I said, you trust your pods, you trust your unit, and verify that they're doing the right thing. And then you teach them how to do triaging. So how to determine if it's something called a vulnerability, if it's a false positive or not. Do I care about it? How do I prioritize? How do I prioritize the work? And then the other element, you schedule the remediation and you schedule the resolution. Now, I want to focus on the last part for a very important reason. How many issues do you think that how many vulnerabilities do you think that a security scanner usually throws at a team like this? 10, 20, 200, 2,000? Throw me a number. 1,000. A legacy application, I've seen 20,000 vulnerabilities from a day to another. How do you think that a team is going to manage that from a day to another? Probably what? Probably they need to schedule a remediation work that's going to span years. And that's where the risk management aspect comes in place. So whenever you schedule the remediation, then you need to schedule the remediation plan. You need to work with the risk people to say which one are the ones that we're going to work first, which one are the ones that are more impacted. And that's where the triaging aspect comes into place. How do I prioritize my work? Which one of the vulnerabilities are going to impact me the most? Which one of the vulnerabilities are going to impact my core application? All these elements drive a prioritization, and you can decide with the business how much time do you need to spend. And that's fundamentally how you do risk management in that sense. But I'm going to dive in a little bit more in what is the risk in normally a software development lifecycle. So you have library, third-party library, code defects, deviation from standards, testing defect. All these can be categorized as security risks. And you have different timeline around this. So in order to fix a vulnerability, in order to fix a code defect, in order to fix a library, you're going to have different time. And every time you can't fix it immediately, you need to find a way to report the risk. In operation, who works in operation here? Well, what do you do normally in operation? same stuff that DevOps people do, because there is no border between Dev and Ops. That's the core concept of DevOps. So you do, again, third-party library, update, patching. You see stuff that deviates from regulation, from the norm, and then you keep on doing that over and over again. There is absolutely no difference between Ops and Dev, specifically the test part. And there is time against this. When a system is live, when a system can go down, you can't patch it, you have a critical vulnerability, what you do, you need to record the risk. The same risk that you record in development. But one element that changed between development, between testing and operation, assuming you have segmentation, is the data that the application gets act on. So effectively the impact that a vulnerability has. And hence that should influence the priority of fixing vulnerability between testing and operation. And that's fundamental risk management, one-on-one given to the engineers. Very simple, keep it very, very simple and straightforward. And that's how you get them doing every day. And just to give you a perception, we're working with 12,000 developers across 64 countries. It's really hard to keep them all updated, to keep them all in line. So you need to give them a very, very simple instruction, very, very simple things to do. And this is just a picture of how long it takes usually to fix a vulnerability from day 0 to day fix. And it's something in average in the industry between 60 and 94 days normally. I've seen much worse. I've seen 18 months to fix a vulnerability. And that should tell you how much time do a hacker have from disclosure to actually exploitation. It's quite relaxed work. It's like, yeah, I can pick up whatever. You just throw Shodan, and for who doesn't know Shodan, I'll discuss it later. Not publicly. But just to dive in a little bit on the technology side of security Phoenix and what we're doing. Effectively, you have code that goes from the code itself all the way to production. You have different phases. And you have scanner at different phases. So you have static code analysis at the very beginning, you have dynamic code analysis, testing, and so on and so forth. And then you have dashboard that you troubleshoot the code on. That usually are the tools dashboard. But then one important aspect, in order to visualize, you need to aggregate and visualize the element into a dashboard. And I keep on referring development dashboard and production dashboard are two separate dashboards because the impact on the data is fundamentally different. So in order to prioritize the work of the team, you need to visualize them in two different ways. So and this is an example of the dashboard, so I'm going to go a little bit quicker. And fundamentally what we do day in, day out is tweaking the threshold. If you remain below that threshold for an amount of time, then good. So, triaging and maturity model. Who loves a maturity model? Nobody loves a maturity model. Who likes to be measured? Nobody really likes to be measured. Especially when I was at school and I hated when my teacher was measuring me against somebody else. But we need that in business. We need to measure for a specific reason. We can't aim for the star if we haven't even started working. So we need to learn how to work, how to triage a vulnerability, how to determine if a vulnerability is a false positive or a non-false positive. And the other element that we integrate is location. Is it facing the internet or not? How impacting is that vulnerability? And then you go on and you go on. So you broaden up the picture and you get better and better at effectively risk assessing our vulnerability. And the nirvana is actually having that completely automated. And if you want and pick my brain, we have a way to automate this stuff. And that's a visualization of how we're doing. So effectively just one score that takes into consideration all of this. So your application owner looks at just one score. And that's a very simple thing. You say, is my application red, yellow, or green? Very simple. And that's the detail around a little bit more in deep around the triage. So you go from the left, when you have very simple triaging, and a maturity model that develops, when you consider more and more things while triaging your vulnerabilities. And just to give you a peek underneath the hood, you start with your risk score that is very, very simple. Those are the number of high, medium, and low that your security scanner throws at you, and you just multiply them and maybe weight them. And then those are the elements that you want to consider to enrich this formula. And if you want to get more proficient at this formula, you start considering the one at the bottom, CWSS, that is the new standard for evaluating vulnerabilities at scale. I'm going to touch point on the education element and then quickly rush through the design aspect because I think we're running a little bit short on time. But go on your development team and teach them exactly these functions. So, how to threat model, how to evaluate a vulnerability, craft your development training based on the result of those standards. There is absolutely no point on keep on hammering security training at people when their problems are different. If you have input validation problem and you teach them about, I don't know, social engineering, they're not going to listen to you because you're not solving their problem. Do education on the job. Security champion, the key role of the security champion is that they teach them how to triage, evaluate, and how to fix vulnerabilities. And make training entertaining because training is bloody boring most of the time. Especially for developer. Capture the flag is a very simple way to actually keep it entertaining, so let them break stuff. So I'd like to conclude with, again, security is everybody's job. The key concept that we discussed today is trust and verify your people. So give them a token of trust, but also verify that they're doing things right. Do risk visualization. Visualize things is one of the most powerful things. Everybody loves a diagram, especially in the management team. Do vulnerability management as part of everyday life, triaging and fixing, triaging and fixing. There is nothing more than that in application security. Don't think that any transformation, especially DevSecOps, is about automation. People come first. Automation come after. Teach them how to do things, then automate, and then rinse and repeat. So a couple of things. As a Cloud Security Alliance, we want volunteer to help us making cloud a little bit better and more secure. So we do white paper, we do webinar, we do conference, and so on and so forth. So if you want to know more about what we do, connect with me or ask what we do. We have, as part of NSC 42, in order to give back to the community, we have a mentoring call. We are sponsoring an award, so the Cloud Security Influencer of the Year. Sorry, I'm going very, very fast. But connect with me, I have more information around this. And yeah, thank you. Sorry for speeding up at the end.